Swayam Prabha. Digital India. Educated India.
Okay, we have a problem in friction that needs to be solved. Let me just explain the problem and then seek to find out a solution to it. Okay, the problem goes like this: there are 3 blocks A, B, C. Okay, the top block is 30 kilonewton, and I think this is an engineering problem where I wish to move this block upward or downward. Okay, whatever the case may be, and what they have done is they have 2 blocks here with a slanting contact between them. Okay. Now this is a wedge, this is another wedge, but in a block shape. Okay. So if I push these two this way, this should go up, right, and if I gradually release this, it will come down. That is the engineering problem. Okay. We have rollers over here, so that there is no friction along this, it is only in a normal reaction that comes on this sides of 30 kilonewton. Okay. These are small blocks, let us say wooden blocks, so they are not heavy, 1 kilonewton I suppose, and the angle is given as 25 degrees. It can be 30, 40 also. I am just taking from a textbook here. Okay, and remember there is a 25 kilonewton and 25 kilonewton. Basically what is happening is there is a guy over there, maybe I am just guessing, and he is trying to push. So the push this way and the push this way are almost the same. Okay, so 25 kilonewton and 20, of course 25 kilonewton is huge, 2.5 tons push is what we are talking about. Maybe there is some jack, okay, and that jack has arms that go towards each other, and therefore you have an equal and opposite force coming up. Okay, I am just guessing a few things over here as an engineering problem. Now there are other parameters given, for example the static friction coefficient between all the contact surfaces. So I presume the contact surfaces is between A and B, B and C, and C and ground. Okay, all these the static friction is 0.3. Okay, the question that, right now is, given that I have applied 25 kilonewton over here, do you think this will move up? Do you think it will move down or will remain stationary? Okay, so looks like there are a few problems that we have to handle this here. Supposing I consider purely statics, what happens? There will be some force over here, there will be some force over here, there will be some force over here, which is a frictional force, but not exceeding mu s times the normal reaction that comes out to each one of these blocks. Okay. Now if this block has to remain stationary, okay, there are 2 possibilities. One is that it is just static, the other could be that these 2 blocks slide. Okay, I am just guessing that that kind of a situation may not occur. Okay, because the reason is you have a 25 kilonewton here, 25 kilonewton here, which means there is no net horizontal force in order to push it this way or this way. Okay. So one possibility is that this, let us look at one of the cases. So let us take case 1, and we are looking at a possibility of 30 kilonewton going up. Shall we do that? Okay. So let us look at the possibility of 30 kilonewton block moving up or down. Okay, well let us just consider moving up. Okay, if this has to move up, one possibility is A and B do not stick to each other, let us say, and this C moves to the right. Okay, that C moves to the right could push it up, that is one possibility. What is there any other possibility? There is another possibility, C could remain as it is, and B goes towards the left. So, if B goes this way, then again I will see an upward moment. The other alternative is that both of them move simultaneously. Okay. In either case, I see that this block has to move to the left. Okay. So, let us look at that possibility first. Okay. So, one possibility is what we are exploring. I am presuming that if I look at that possibility, there are many other things that we will understand from that possibility. Okay. So, let me just draw only that block. I have a slanting contact over here, there is a 25 kilonewton coming in on the side. Since there is no sideways friction on this block, okay, there is only one vertical force that is acting on B, block B from A, okay, and that is 30 kilonewtons. There is no problem about that, right. And I could have, since it is moving this way, I could have a frictional resistance to that movement. So, I am assuming that the movement is in this direction. Okay. It could be an impending movement, okay. But remember, in a frictional problem, if I am looking at limiting cases, remember I am again repeating this, in a frictional problem, if I am looking at limiting cases, I have to assume a particular kinematics that is impending, very important. Okay. Here the kinematics that I am thinking of is that this block moves to the left. Okay. That is one important thing that I have to do. Given that it is going to move this way, the static friction will reach its limit, right, equal to mu s times 30 kilonewton in this particular case, because 30 kilonewton is the normal force that I know. Here there will be a normal force. Of course, if there is equilibrium, I can find this force. If there is acceleration, then we need to worry about it later, right. And again, since the movement is in this direction, there is a resistance offered toward in the opposite direction to the movement, and therefore this will be mu s times okay. Let us just draw the angles. This is 25 degrees. So, let us say this is 25 degrees, okay. So, this is 25 degrees, all right, and there is also a weight coming onto this, which is 1 kilonewton. Anything else that I have missed? I have almost done everything. Now, this is the free body diagram. Remember, I have assumed a static case, okay. That assumption itself may not be holding true, but let us say for the given condition that I have, it is in statics to start with, okay, and let us say the movement is impending only, okay. So, in which case mu s times 30 and mu s times n makes sense, okay. Now, after that it is very simple, all I need to do is the equilibrium equations. Vertical components 25 does not take part, mu s n and n will take part, 30 kilonewton will take part, 1 kilonewton will take part. So, again I will write, so I can take upward direction to be the direction positive. This implies that I have 30 plus 1 minus 31 kilonewton downward, right, plus n times cos 25. Let me just assume theta first, okay, and let us say theta is equal to 25 degrees. This will help us later. This will help us later, so that in case I have to change the angle, okay. The direction of mu s times n is in the downward direction. So, it is minus mu s n sin theta, alright, and that should be equal to 0. This is pretty simple. I can find out n from this directly. Okay, what is n? N equals 31 divided by, I have a cos theta minus mu s n, right. So, cos theta minus mu s sin theta. Let us substitute values and see what we get. If theta is 25, I think you do not have a calculator right now, no problem. If it is 30, cos 30 is root 3 by 2, sin 30 is 1 by 2, and mu s is 0.3, right, and roughly what do I get here? Root 3 minus 0.3, root 3 is 1.7 odd, minus 0.3 is around 1.4 by 2, which is 0.7, roughly around 0.7 is this quantity. Okay, 31 by 0.7 works out to around 30% more. Okay. So, it may be shooting up to around 40 kilonewtons. I am just looking at a ballpark figure here just to understand, alright, and remember I am just doing it extempore. Having done this, now it is possible to find out whether this possibility exists. The question that we have right now is there a possibility that this could exist, right. Now I have a force due to resistance due to friction in towards the right hand direction, similarly resistance towards due to friction in the right hand direction, and there is a 25 kilonewton which is offsetting it. Okay. So, if I have to write horizontal equilibrium, so I can write sigma f x equals 0, let us say this direction is positive, this implies I have mu s times 30 kilonewtons, this one, and this one is mu s, so it is also plus mu s n, and that is a cos 25, or let me just write it as cos theta, okay, minus 25. Okay. If this is equal to 0 implies impending. Please remember what I have written here. It is a very important thing that we have to remember. If there is an impending motion, that is when I take it to be 0. If it is in motion, let us say there is an acceleration, remember it is not equal to 0, it will have mass times that acceleration, alright. If it is not moving, if it is not impending, these assumptions that I have made are not correct. So, remember so many assumptions that I have made, okay. But what is true here is this value mu s times n or mu s times 30 are the highest values that are possible if it is in static condition, and therefore, if the values are lesser, we will find out what is happening. Okay. So, let us look at this. These two are the frictional resistance. I am going to add this word limiting. Okay. I am adding this limiting because this is an impending assumption, impending motion assumption. This is an important thing to remember, okay, because when we do this we just assume statics and just go on, do not bother about what is happening to the structure, alright. So, this is again impending, this is impending, this is only due to the frictional resistances, and this is what is applied, alright. Let us just estimate what could be this. So, I am going to do a rough estimate here. Mu s is 0.3, so this is 0.3 times 30 this happens to be 9 kilonewtons, and I have a cos theta times mu s, that is say plus 0.3 times cos 30. If I take theta to be roughly 30, cos 30 is root 3 by 2, which is around 0.7, alright, 0.71, 0.7 let us say, this is roughly I am just writing. So this together will give me 0.21 times n is given by this, with this around 43, okay. This is roughly around 43 kilonewtons. For want of calculators, I have just put this. So it is 0.21 times 43, roughly it is around 8.6, 8.7, okay. So roughly around 8.65 kilonewtons, okay. Have I done this correctly? This is an important step. Have I done this correctly? Most of the times we make a mistake here. Have I done this correctly? Let us assume this. If mu s is equal to 0, these two are gone, only this exists. How come? Because I have missed out this n has a component, right? And what is the direction of that? That is also in the positive direction. So it is plus n times sin theta, right, okay, and this is due to the weight that is coming onto it, right, this is due to the weight effect. So I am separating them, one is the weight effect, the other is frictional effect. Of course I cannot separate the two directly, but just to get an idea, okay. What is the rough value of this? This n is around 43, so let us just write that also. So let us say this is weight effect, just to get an idea, and what would be the weight effect? This is 43 kilonewtons times sin 30 is around 0.5, and that gives me around 21 kilonewtons. So supposing mu s were 0, then you find that this is around 20 to 18 to 20 kilonewtons force that is offered in terms of sliding, okay, in terms of moving this way. Is that clear? Okay, and therefore if I look at all of them together, this 9 plus approximately 9, 18 kilonewton is friction is offered, roughly almost the same amount of forces offered by the weight effect, okay. And if I have to think of a resistance, resistance will come in terms of, for example, if I have to push this all the way like this, the resistance will come from this and the weight effect. So I have to offset 18 plus roughly 18 again, or let us say 20 plus 20, I need to have at least 40 kilonewtons in order to push this guy. I have done a very rough calculation, but it is very useful to me now. And remember what I have done, I have looked at the limiting case of resistances, I have looked at the weight effect, okay. Supposing there were no friction at all and I have to hold it in place, I need to apply around 20 kilonewtons in order to keep it in place, alright, but the frictional force is enough to keep it in place in this particular case. Is this clear? And remember, this is impending motion in what direction? Leftward. Let us just make it a little different. Let us say the movement is this way. When will that occur? When will the movement occur this way? when this is pushing it and this is sliding down, correct. Let us look at that particular possibility. So this is sliding, what all will change here? The directional frictional force are the only ones that will change, right. The direction of frictional forces will affect to a certain extent this normal reaction, but remember mu s times sin theta is roughly around 0.5 times 0.3, around 0.15 or around 15% is what its contribution is, okay, and cos theta is roughly around 0.7, and therefore the major effect is due to this cos theta, okay. Now the reason why I am putting this here is there will be a plus sign coming the moment it is the other direction, alright. Now look at this carefully, this is the resistance that we have now, okay, this is due to, this is the direction only has changed now, okay, and this, how about this direction, will it change? Will not change, this direction will remain the same, right, and what is the direction of this? Like this. What is the direction of this? Like this. Let us look at, forget about this right now, let us look at these two effects. This guy needs 21 kilonewtons to approximately to keep it in place. Do I get that 21 kilonewtons from here? Roughly okay, 18 kilonewtons is what I am getting from here. The remaining I can supply through a force 25 kilonewton because it is opposing the motion towards the right hand direction, alright. So 25 is more than enough for me to keep it in place. So two things that I have found out now, the movement is not to the left, the movement is not to the right, because I have already shown that 25 kilonewton is more than enough to keep it in place, and if 25 kilonewton has to push it to the left hand side, the possibility does not exist, we have seen that. So left hand side movement is not possible, right hand side 25 kilonewton is more than enough for it to keep it in place, which means it is in the static condition as far as this block is concerned. So far so good. So one of the good things that we have seen is that this guy is in stationary condition, this and this together are now occurring. There is one possibility of pushing this, okay. If I look at that possibility and discount that, then I know the entire thing is in static equilibrium. Okay, we have seen that A and B do not move relative to each other because of the earlier exercise that we did. Now let us see if only wedge C can move towards the right, in which case it can go up. There is an up or a down possibility, okay. So let us look at those possibilities. Now if this goes towards the right hand direction, the resistance is offered by number 1 the frictional force that is coming on because of BC contact, and the frictional force offered by ground onto this wedge, okay. The other resistance is due to the component of normal reaction, okay. So let us just write those. So I am just going to write Fx components, okay. First let us look at the resistances to this application of force. One resistance is due to the friction below, that is 0.3 times 32 is 9.6 kilonewtons. This we already found out is mu s times 43 times 0.7 or so. So that came out to be around 8.7 kilonewtons, right. So these are the frictional resistances. Then the other resistance that comes in is due to this normal reaction, and that is 43 times sin 30, okay, and roughly around 0.5, that gives me 21.5 or let us say 21 kilonewtons, okay. So there is a resistance in terms of the normal reaction which is 21 kilonewtons. Remaining 4 if is taken by the frictional force, then the block cannot be moved by 25 kilonewtons. I need to overcome the frictional forces in order to do that. but the frictional forces themselves account for around 18 kilonewtons. So, in which case if I have to move this, apart from this 21 adding 18, roughly I should have 40 kilonewtons force in order to move the block up. Okay. Let us look at the other possibility, can this wedge move towards the left hand direction. Okay. If it is moving towards the left hand direction, the possibilities are it has to resist this 25 kilonewtons, it has to resist the 2 frictional forces now in the opposite direction, and therefore 21 kilonewtons should be able to push this to the left, but the resistance by friction itself is 18, the remaining 3 or 4 kilonewtons is automatically offset by this 25 kilonewtons, which means that this wedge C is also in the static condition, and therefore there is no movement that occurs from what we have found out. Okay. And I have done a rough calculation, specific calculations you can do in order to understand this completely. Okay. But as we have seen already here, looking at the limiting conditions, it is within the limits of movement in one direction or the other direction, and therefore it is in the stationary condition. All right.